yeah, we have definitely good stuff. So hello everyone. I'm this guy, Greg, and here is Ram, the original founder of this group. And so today we're going to speak about
我是不是抓你的椅子？
we're going to go into this, which is basically the next generation JavaScript. It's kind of available now with some restriction, and it's going to be like the next huge improvement of JavaScript. Basically, now JavaScript is a super shitty language with a lot of really bad things inside, and with the next iteration, it's going to be much more usable with a much more nice stuff coming from Python and stuff. So let's get started. So yeah, quick intro. So right now I'm a full-time Node.js developer. So JavaScript on the server. I really like everything like web related and stuff, and I've been doing this like web stuff for about 2 years now. And Ram, who is just here, he's also a full-time JavaScript Node developer. He doesn't want to admit that too much, but he also worked with PHP before and Java, a whole lot of programming language, and he's really interested in like performance and also security. So how come JavaScript came into existence? It was created in pain days, which is kind of crazy and which explains actually a lot of things, by one guy at Netscape in the very early day, and then it was brought to ECMA, which is a standardized organism in Europe, like to make this language a real standard. And also, like I have to say, like JavaScript has nothing to do with Java. The name JavaScript came from a marketing error, because at that time, in 1995, Java was really popular, and people behind JavaScript wanted like to use this popularity for their new language. So they chose, originally it should have been called LiveScript, and then it's now JavaScript. So yeah, nothing to do with Java. After that, so ECMAScript, there was like multiple versions, on some wars between like Microsoft and Netscape and stuff. It has been quite troublesome to come with a unified standard. And now so ECMAScript is a standard, and there is JavaScript, which is one implementation. The other well-known one is ActionScript used in Flash. And basically it's now super huge because JavaScript is assembly of the web. That means if you want to code something for the web, you have to code, like the target should be JavaScript, because browsers only understand JavaScript yet. And also there is a lot of confusing version number. So JavaScript 1.8 is actually corresponding to ECMAScript 6. So usually don't refer to JavaScript version number because it's unreliable and confusing. And now we are going to talk about like this bad guy and this standard. So yeah, this standard has been started like a long time ago, and it's not finished yet. Like the spec is almost done, all the API is frozen, and there will be no major enhancements. So you can consider the spec is done, but it's not yet available everywhere. And if you want to use it, it's clearly not production ready. There are lots of stuff in here which are not kind of not stable or just not good for performance. So for a production system, it's not recommended, and the support varies widely. Also, a big disclaimer: this changes fast. So if we say something is not supported today, it might be supported tomorrow, or all of this like it's moving really fast. So this talk will be obsolete in a few weeks. So you are encouraged to just look on the internet and see when you can use this feature or not. So this is basically what we're going to talk about. So there is, as you can see, there is quite a few things. The support part, you will see this everywhere. Basically, you have like where it is supported. Yeah, I added IE because it actually supports. IE actually supports one or two things. I didn't put Safari. Basically, the Safari and IE support are the same, minus one or two very minor exceptions. I haven't yet also talked about Node.js because Node.js is based on V8, which is the same engine as Chrome. So if Chrome supports it, you can consider Node support it. It's basically the same. And for Firefox, it's usually supported. For some newest feature, you might want to grab the latest build, like the Aurora build, or add some flags. Also, about Chrome, nothing is supported in the standard Chrome browser. You have to enable experimental JavaScript feature inside the menu. So yeah, definitely not production ready. And here, when you will grab the link after, there is a full link to this table, which cover like everything. You have like a lot of browser and all the feature one by one. Is it supported or not? So let's go back to This one? F. 11?
No, just F.
Yeah. Cool. Okay. Yeah. So for Node, you need at least the latest version, and you need to add that with the flag. And for Chrome, you also need this kind of flag or tweaking with the internal settings. Safari is the same as IE, so basically it's not ES6 really at all. And let's talk about the scoping, which is actually supported in IE 11. You won't see that often. So what is the scoping? We get block scoping, and I have to say finally, like for anyone who has written like more than 20 lines of JavaScript, he knows that the scoping is completely fucked up. When you call something, when you call a function, and then you call the same function with an asynchronous event later, so the context of this function has changed. And this takes a while to understand really what's going on. And how you call the function, everything changed. And if you declare some variables, it's actually leaks everywhere. It's a huge mess. So basically, here, so inside the for loop, I declare a variable I iterate over stuff, and I do whatever. In any like normal language, when I exit the for loop, the variable I is not defined anymore because it should be restricted to this part. But here, like I still have I, it still works. So that means the scope of the variable I is not limited to this. It's limited to the function or the global if you are in the browser. So yeah, this is how it has been until now. And now we have a new keyword called let. So if you use let, it has exactly the same effect as var, but then you have like block scoping. So this is restricted to this area. And if you try to access this variable outside the loop, you're going to get an error in strict mode. Or just nothing if you are not in strict mode. Anyway, this is like the usual thing. Like if you come from Java, Python, Ruby, or approximately everything else than JavaScript, you will find this, it makes completely sense. The let works with absolutely every block. So if this works too, here I can define a new variable, even with the same name, and the log here, it's actually going to be this variable. So this variable, because of the let, is restricted to this block, which is pretty good. It eliminates tons of like nasty bugs or just like insanity for beginners. It also makes closures easier because now, like this is a traditional example. You have an array with some stuff inside, you have a loop, and you want to declare an asynchronous action to do over this array. So basically, every like in 500 milliseconds, a second and a second and a half, I'm going to output. I want to output first rum, banana, and then Nutella. By the way, if you put these three on a crepe, it's super good. But this actually doesn't work. The output will be Nutella, Nutella, Nutella because I haven't written that. So basically, what's going on is this var is not limited to the for loop. So the var definition, you can actually write that at the top of the program. It's exactly the same for the JavaScript engine. And then, when you call this variable, a of I, the I is still going to be in the outer scope. So in the end, so you're going to loop over the loop in synchronous fashion, so in 0 milliseconds, and then at the end, I is going to be equal to the I is going to be equal to the last one, so Nutella. And this variable will refer to the same one. So you're going to see Nutella 3 times, which is obviously not you want. This is a great interview question, by the way. If you don't really understand what's going on, study it if you want a job in JavaScript. This is really useful. The easy fix is just like you declare this variable with just a let. And now it's local to the scope and everything works fine. So you don't need to create some crazy clauses and put a function inside to make sure your variable is not going to change when you call that later. So yeah, basically that's how JavaScript will look in a few years everywhere, and it's going to be much nicer. So if we recap how let works, it's exactly like a var, but now the scope where you declare your variable is limited to the brackets. It works for like for loop, try catch, if then else, or whatever. Also, there is a new keyword called const, which is exactly like let, but it's read-only. So you can assign it once, and then it's a read-only variable. That means like this will throw an error. By the way, use strict, it pays to know exactly what it does, because if you don't use strict, this will do nothing. It will just fail silently. And good luck to see what's the bug after that, because you think I will be equal to 5, but no. So yeah, const is pretty nice. I don't know how it impacts performance. Basically, every time you can tell the engine, hey, I'm going to use this variable in such way, it's probably good for performance, but I don't know. So this is probably useful, but anyway, it's good for other fellow developers. You say this is not going to change ever. You don't have to be worried about it. Okay, and also like because it's exactly like let, you have the block scoping of let. So you can find that inside the for loop or whatever, it still works the same way. Next, let's talk about destructuration, which is currently only supported in Chrome 24, so it should be the current version you have. Everyone should have this one. Destructuration, what is that? Basically, you can do this. You have an array, and you can directly assign multiple variables to the different arrays. It also allows you to swap two values. So yeah, I think the code speaks for itself. This is not fundamental. It's just syntactic sugar, and it's pretty nice to use. You can also do the same thing with functions. If your function returns this array, you can then use a destructuring assignment with the return value of the function. You can also specify, I don't care about the first two values, I just want the last one, and it works the exact same way. Although the last line is definitely a little bit weird. But anyway, like, yeah, you don't have to access a specific element inside your array with the square bracket notation plus the index. You can do that with objects too. So let's say we have a function which returns the date, which is actually today, as an object. You can directly declare your variables and assign them at the same time using this destructuring assignment. Again, nothing groundbreaking, but it's still like pretty nice to use. And you can also, and this is really nice, use that as an argument of a function. So basically, you have like you have an array of objects, and inside you can directly use declare your variables and assign them to the hash you're given as an argument. So this, like the example using traditional JavaScript would be to declare your variable var name equal the argument dot name and stuff. So again, it's not groundbreaking, but it it makes really like a nice program to read. In the same way as the function, again another improvement is the default function parameter, which is pretty nicely supported. So you don't do that anymore. If I don't have an A, I assign something else. Like you see that everywhere in JavaScript because there is no default parameter. Like literally everywhere. Like any library which is more than 200 lines of code will have this somewhere. But now you can do this, which is very nice. Like you can see instantaneously what you want to do with this variable. How does that work with undefined and null? It works with undefined but not with null. So for example, I have this, and y and z are some default parameter. And this is going to be the end result. Why? Undefined in JavaScript represents something which has not been defined yet. Yeah, I know it's the same. So basically, it's something which has no value yet. When you create a new variable, for example, well, if you just write, let's say, var x and nothing, x is undefined at that point. It means there is no value. Null, on the other hand, says this is a null value. This is a value. It's actually a value, but it doesn't exist. It's a special value. If people do Python, nil is pretty close to null. Null in Java is exactly the same and stuff. Also, yeah. And so the engine considers that when you give null, it's actually you really want to give something. It's a value. It's a non-value, but you give actually something, which is different than undefined. Like if I don't specify the subparameter, it's by default it's undefined, and then it's going to trigger the automatic evaluation. So yeah. Just be wary of that. This can be kind of confusing, but usually when you don't have any variable, you're just not going to write them. About the arity. The arity is okay. The arity of a function is the number of parameters this function takes. So, for example, let's say I have this one. The arity of this function is 1 because it takes one parameter, basically just one thing here. When you have default parameter, the arity is the number of parameters without default value. So this is 1. There is a default value, so this is 0. And here I have one default value and no default, so this is 1, 2. And you can get the arity with just the function .length. So yes, that's about it. If you, for whatever reason, you want to know exactly how this function should be called, if you want to do, let's say, function decorators, when you wrap a function inside another one and you want to know some specific stuff, this might be useful. Now let's talk about REST parameters. Since this is quite different, just maybe, is there any question about scoping and default parameters?
Maybe about let. Let the function let is not always apply. So what do we need to write it? We need to write let like in the function.
What do you mean?
Like if there is a new version, it's not possible to make it like imply it's always like this.
Yeah.
So the parameter will not like be like a bit like weird like it was before in JavaScript. Do you know what I mean?
So is the question is about can I use let in older version of JavaScript?
No, the newer version, like why is not like already implied, like when you write the let would not be like automatically implied as well. Like it could not work all the time?
No, it's mostly for backward compatibility. You cannot take var out of the table.
Oh, okay.
Because like all the standards should be as most as possible backward compatible, so you cannot just change the behavior of existing things. Otherwise, if you do that, you will end up with some situation where you have some kind of code which runs differently in different environments. And since in JavaScript you don't control the environment when it's on the browser, good luck. Yeah. Any other questions? Okay. So let's talk about REST parameters. what is this? Basically, you can use that as a better than arguments. So this is a slide just to show you how fucked up arguments is. Arguments is a keyword which represents as a kind of an array all the arguments your function has received. But you can also name them. So I expect a function with a name. Here I output the name, whatever it is. Okay, fine. Then arguments of 0, so this is the first argument. I'm going to replace that with me. And magically, it's going to change the name parameter name. Okay? So if you don't know this, like this is super nasty. And also, if you test is arguments an array, you will find it's not an array, which is confusing because this is actually an array syntax. Okay? So basically, the arguments keywords is useful, but very limited and has some super weird behavior. These two lines are super, super weird. If you have a bug involving this, good luck to debug it. Now you can do this kind of thing. By adding these 3 dots, it means it's a rest parameter, so it tells the engine this should be an array. So whatever I have like as arguments, put that inside an array and call this array args. So now I have a real array. Cool. And this is like regular arrays. And you don't you gain a lot of things. There is a lot of benefits. So for example, this is a question. This is an example. So I have a function like which make a number declaration about someone, like a name and some qualities. And then it outputs the name and then the qualities. You put all of them together and you join them with n. So with this, I don't need to manipulate the arguments. And the join method is actually not present on the arguments. You can just you have to convert the arguments into a regular array, and then you can call join. But with the rest parameter, it's already an array, like regular array, everything where it's perfect. And so you get this output, which is totally true. There are some restrictions though. The rest parameter must be the last one on the function. And there can only be one rest parameter. This actually makes sense when you think how you would implement this function, this feature. If you have 2 rest parameters, how do you know when to stop? When the first one stops and when the second one stops? If you have this kind of stuff, it's also like what args should be if there is no callback or stuff like that. So if you actually write that, it's not even going to compile. When the engine parses the function, it's going to say, yeah, invalid, you cannot put the rest parameter at the end, at the beginning. A few details. It's always an array, even if you don't give anything. So if I call f with nothing, name will be undefined, but more still will be an array, and it will have a length of 0. So a rest parameter can never be undefined. So you don't need like default arguments for rest parameters, which is like pretty nice. It will avoid like some if and logic. Also about the arity, rest parameters are not included when you compute the number of arguments for a function. So yeah, the code speaks for itself. So about the spread. You will see like very soon I'm going to explain the difference, but there are 2 levels of support only in Firefox. As you can see, like Firefox is pretty nice to support things actually. That's the definition you will find in the specification for the spread. You can expand an expression where multiple arguments or multiple elements are needed. So basically what you can do is use it as an array manipulation. Let's say you start with an array, let's say from, and then you want this output. So basically what you want is you take the array from and you add 0 and 3. Using like ES5, so JavaScript of today, you have to do this kind of stuff, unshift and push. And yes, I had to read the doc about unshift because I keep forgetting like shift and unshift, how does that work? So you have this kind of stuff, and then push. So basically you take 0, you put that at the beginning of the array, and then you add 3 at the end. And also like if you need more array manipulations, there is a splice method, which is also like kind of tricky to use. And so it exists, but you have to do this kind of stuff. And now you can do this, which is exactly how I specified the problem. I want 0, my array frame, and 3. And here, the implementation in JavaScript, I just add the 3 dots, and that's it. That's just beautiful. Perfect. So basically, that's the spread when you want to use it with array. It can be used if you want to convert an array-like. And now I have a few things about array-like. This is again a concept, a messed concept in JavaScript. Basically, the history is like JavaScript has been made in 10 days, so there were a few things missing in the first version. The array with all the methods you have on the array is actually not present in the first version of JavaScript. It appears like a year after. And so that's why the DOM doesn't have array, like true array. So basically an array-like, it's an object which looks like an array, which acts like an array, but which is not an array. So this is an array-like. Basically all the elements are indexed with numbers, and there is a length property. This is enough for JavaScript to consider this object as an array-like. Yeah, so the arguments in functions, it's an array-like, and all node lists from the DOM. So if you do something like document dot query selector all and div, you will get all the div, but so every element will be a DOM node, but they will be grouped in an array-like. So usually you have to convert it into a regular array. So yeah, that's basically an example. Here, nodes, I'm going to have an array-like, but since array-like sucks, because there is basically nothing with them, you call this. This is standard. Everyone does that to convert the node array-like into a real array. The problem with this line is that the first time you see it, and the 10 times after, you are going to say, what the fuck is this? And why is this necessary? Just to use nodes as a regular array, you have to do this, which requires you have to know slice, you have to know colon, you have to know exactly what array dot does, which is quite a lot. And then when you start to Google everything, you are going to end up with what is a prototype, how do I extend my prototypes and stuff, and what is call, how do I fix the context. So yeah, this is standard but messed up. And now you can do that, which is clearly like, I want an array, so I have my square bracket, and I use a spread operator to convert this into an array. So yeah, you will still have these kind of weird lines, but actually if you just put a square bracket there, at the very beginning and the end, and you have the 3 dots, that's it. And in one line, you have converted an array-like of DOM node into a true array that you can use properly. That by use properly, I mean you have everything a regular array like filter, map, reduce, splice, push, and shift, and stuff. So yeah. By the way, it's outside the scope of the talk. ES6 also introduced this array.from, which does the conversion. So this works too. We are not going to talk a lot about this because like there is, I think like at least 20 API improvements of this sort. Like they add a lot of things to the regular array, like basically more nice stuff like that. And also, so now the second use of the spread, you can use that with a function, which is basically a better apply. And usually at that point people ask, but what is apply? This is the full signature, that's where you can find apply. It's a method you can find on all functions. So all function, when you define a function, there is an apply there. And what does it does is you use it this way. The first argument is the context of the function. So when you call your function, this is, by default, it's unknown in JavaScript because it depends on how you use this function. But if you call apply, then you can specify the receiver, so the context, which is really useful for lots of reasons. And then the second argument is an array, which contains all the arguments which are going to be passed to the function. So when you want to call a function, but you don't know how many arguments you should give to this function, you can use apply, which is actually very useful anytime you try to be fancy with functional programming and you want to wrap function inside functions. So how do you use apply? It's actually like this. Let's say, so you have this function and you just want to output all the arguments. You can give this function 100 arguments if you want, or 1,000, but by default it's not restricted. So for example here I give it these 3 arguments, but if this array is a dynamic one, let's say I get this array from the server. By default I don't know how many items I will have there. It can be like the list of your user for your website. So then you will have to call apply, and then you have to go through all of this. So this is basically how you call apply. And now with the spread, you can just directly call your function with a spread operator in front of your arguments. And this will work. This is exactly the same. This is slightly different than apply because you don't fix the context. But usually, like half of the time, when you call apply, you don't care about the context. You just care about the arguments. So now you can do this way, which is much nicer. And it works exactly the same. Like A can be anything. It can even be a DOM list, and it's going to be converted to a true array and then given to the function. And you get some sweet syntax. You can use multiple spread inside one function. So if this function accepts 6 parameters, I can give the first one, use an array for the next 2 one, give the other one, and use another array that I declare on the spot. So you can get this kind of, I call that sweet, but I should have called that crazy. Well, you can do a lot of things. Like it's really powerful, and maybe like this is more to show you how like all the different ways to call the spread operator on a function. But I wouldn't like to see this too often in my code. Yeah.
Can you put an array of array? Spread an array which contains arguments.
You mean like 3 inside an array, for example?
Like those parameters, -1, the spread A3 inside another spread array.
Inside an, so you mean you want that in an array and then you spread it? Yeah. I don't know. I have no idea. Does anyone know if you can nest spread parameters? Okay, so I don't know. You can try that to grab the latest Firefox, and then you add you can try it. I don't know how it will work. I'm not even sure it's supported. Okay, the last use of the spread array is you can use it for new. You cannot do that in JavaScript. It's not allowed. You cannot call apply. So if you have a constructor which expects a variable number of arguments, you're screwed. You have to find another way because you cannot call apply when you construct a new object. Until now, and then you have the spread and you can do that, which is perfect. So read date fields can be anything, like you read something from the database or from the server or whatever. You get an array of stuff, and then you instantiate a new object with it. So much nicer, much clearer, probably faster too. So yeah, that's the last use of. Oh no, there is also this. If you want to add multiple objects inside an array, this is how you do it in JavaScript or use concat. So yeah, it's the same as before. The first time you see this line, it's like, what the hell? And you see, what is this? Why do I need to apply an A and stuff? So this works, this perfectly works, but it's kind of weird. And now you can do that, which is exactly the same. You convert your array into all the arguments you have to pass to the function, and it works. This is a silly example, but again, if the to-push array is dynamic, you don't know how many elements you have, then it's super useful. And that's all for now. Let's recap. Is there any question about the spread parameter and the rest argument? Okay, cool. So Ram is the next one, and he's going to talk about iterators.
That's right. Still awake. So iterators and after this generators, actually my favorite part of the spec. At the moment, only in Firefox. I think Firefox, well, this is 24, but I tried it in 19, so everything works in that as well. So if you've programmed with other languages, you already know what iterators are. So basically, you have a list of items, and you just want to go through the list one by one. And an iterator is just the name you give to the mechanism that lets you do that. And the reason you'd want to do it in a special way is maybe you have a list of 100 items, but you only want someone to look at 10 of them. So having an iterator allows you to control access to your list. So this is basically taken from the spec. You don't have to worry too much about that. I'll show you some code. Yeah, so this is what it looks like. So I have an array, and I get an iterator, and then I just call next, next, next until I can't do it anymore. And when I call next, it'll give me the value, the current value, and it will tell me if there's more stuff I can get. That's from the done process. So once done is true, value is undefined. So at that point I know there's nothing left in the array. So an easier way of doing exactly the same thing is the for loop. You've seen for loops in JavaScript before, but the new thing is off, for something off A. And that does exactly the same thing, so most likely you'll probably be writing this one. So this is, if you've done, I think, Ruby and CoffeeScript, you'll have seen this kind of thing. So I want to get, as you can see, I want to get everything where the color is blue. And instead of writing a big function, I can just basically, there you go, little bracket here. So I'm basically creating a new array, and that's the logic I use to get my new array. So I get every element out of A, and then I do a quick condition check. And if it passes true, then it fetches the color value and outputs it. So it's quite a nice little way of doing that. So the iterator is really useful for arrays, but really what makes it really powerful is you can use it for any of your objects. So here we have a class, which is just a function, and we've got our array inside the class. Now we want to have an iterator for the class. So what we do, so this is so I tested this last week, so it might be different this week, specifically the name of this function. So this definitely works in Firefox. So you create a function on the class called @iterator, and we essentially have to replicate what the engine expects when it sees an iterator. So I'm returning a value and a done flag, a value and a done flag. So what this really says is keep returning values until I've got none left and then finish. So once I have that done, I can then instantiate my class, and then as I did with the other iterator, exactly the same code. It works. It all works. And because this function's on the prototype, if I create a subclass, I can override it in my subclass, which is really nice. So, everyone follow that? Okay. All right. Okay, so now that you know how iterators work, we can talk about generators. So this is like the most exciting thing for me in JavaScript and ES6. So a generator is a special type of iterator. And a generator is something that you get by calling a generator function. So that's just the spec, and I'll explain. Yeah, and this is really the key thing. This is why I like generators, is they're going to change the way you do asynchronous programming in JavaScript. Or I think they will anyway. Okay, here we go. So it looks like an iterator. The key thing to notice is the star in between function and the brackets. So if you declare a function like that, that's a generator function. So what that means is, when you call the function, it doesn't have a return value, a normal return value. It returns what calls generator. And so what that means is, it returns something that I can iterate through. So I get HW, and then I call next, next, next. And just like an iterator, I get the values. One other thing to note is the yield keyword. So the generator function is the same as an iterator. It needs to somehow give values back out, and that's how you do it. You kind of yield values. It's kind of, yield just means to give. So you're just giving values out of the function. So the rest of it's the same as an iterator. I keep going until done is true, which means I've got nothing else that's coming out of the function. Okay, a bit more complicated, right? So we have the generator, and now what we're going to do is we're going to pass values back into the generator. So I call the generator function, I call next, and it gets me hello. And in the next call, I pass in world, and then that gets stored in the next word variable. And then I then yield that word back to get world over here. So it's a bit complicated, so I'm going to go through that step by step so you can see how it works. Okay, so it's the same function again. So what I've done is I've added some console.log, so like this thing here and this thing here, just so you can see what's happening at each point. So here we go. So we hit hello world. So it goes here, it sees it's a generator function, okay, so immediately it comes back and stores the generator in the variable. It then goes here to next. So when next gets called, it then goes into the function and executes the first line. So yield 1. So this is the console. This is your console on your computer. So it's got the output. It then goes to the next keyword, yield. At that point, it switches back out into the console call at the bottom. And that's the return value from the generator. We then go to the next call. So this is where we pass in world into the generator. So that gets stored in next word. We then go to the next line and gets yield 2. It then yields the word we pass in, which we then output down here. We then do the next call. It goes in, outputs that to the console. At that point, the function is finished, and done is true, and there's no value left. So that's how it works. So what I want you to see is how it jumps from that function to here, to here, to here. It keeps jumping back and forth, which is a little different to how things normally work. And the other point to mention is the code inside the generator doesn't start executing until you call next the first time. That's an important thing to keep in mind. And what about throwing errors? Oh, wait, let's go down. Here we go. Right. So this time, almost the same, but I'm going to throw an error here instead of passing a value to the generator. So same thing again. I go to get my function, I get my generator, I call next. Go in here, it yields 1. It then sends hello back out, which I output to the console. Now I throw an error. At that point, I just get an error over there. And I'll show you exactly how we can handle that error in a few slides after this. So at this point, thing to note is the rest of this code hasn't been executed, and it won't be executed. We've stopped it. Okay. Any questions about that?
Blocking model?
Sorry?
Does the yield block
Yeah.
the whole thread?
No. It just passes control back to the other side. Okay, so how do generators make asynchronous programming easier? So this is really the key point behind generators. There's no point using them, in my opinion, otherwise. Okay, so here we have, let's see if I can speak. Oh yeah, cool. Okay, so here we have a function. What I'm going to do is I'm going to read 2 files, and I'm going to output the contents of those files. So this is how you would normally write it with error handling. So this is how you would actually write the code properly. So I've got the first function, the read file function at the top. So don't worry about what that does. The only thing you need to note is it has this second parameter, the callback. So once it's done reading the file, it's going to put the contents of the file into that callback function, encode it. So then I have my main function. I read the first file. This is the callback that gets passed to CV up there. I check if there's an error. If there is, I finish, or I output the contents of the file to the console. Once I finish that, I then read the second file and I do the same thing. And then down here, I have the main call that starts the program. And this console.error here, this is what gets substituted for the callback up here. So any errors I get will get output to the console. So if you use promises, or you came to our talk a few months ago, so promises are kind of a recent innovation which allow you to do the same thing in nicer looking code, basically. So again, don't worry too much about what this does. It's a function which does the same thing. It reads the file and it gives you the contents back. And it returns a promise. So I'll just quickly explain what a promise is for people who don't know. A promise is basically saying, go and do something and come back and tell me once you're finished. And what it's kind of saying is, okay, I promise you that I will come back and tell you either that here it's successful or here there's been a failure. So that's all a promise means. So we do the same thing. We call read file. Then means once we've read the file and we got the contents, output the contents, and then immediately read the second file. And again, we do the same thing. And if there's any error, any point, catch the error and output the console error. So you can see why this is a little bit better, because in the previous version, we had to handle the error in many places. You handle the error here, you handle the error here, and then finally output the error here. Whereas here, we only have to handle the error once. So it's a nice improvement. You can do a lot of calls, do a lot of asynchronous stuff, and only handle the errors in one place. It's really nice. But this is still not that great. And this is why generators, you'll see how good we can make this with generators. So before we do...
just one thing, like the example with promise, you can use that right now. It's
yes.
JavaScript, ECMAScript 5, like completely compatible everywhere.
Yeah, so we'll mention this, but promises will be in ES6 natively. But there are lots of libraries now that will let you do that same thing. And I'll mention a library which is a good one. So before we do the version with generators, if we go back to the code for generators, one of the problems we had was, this code. So one of the problems we have is we have to keep calling next. It's really annoying. So you have to know how many times do I need to call next inside this generator. So wouldn't it be nice if I could just make that automatic? Just call next as many times as you need to call it. So in order to do that, what we'll do is we will write a function. Yeah, here we go. Yeah, this is really small. Does everyone see that? Called run generator. And the whole point of this function is to call next. So I'll quickly go through it. So you pass in a generator function. It then gets the generator. And what it does is it calls next on the generator. And then it checks to see if the generator is done. If it's not done, then this bit here is basically the asynchronous call. So we're going to assume that our generator always yields a promise for us. That just makes this code a bit easier, that's all. So once the asynchronous call has succeeded, we get the answer from that call, and we then call the same function again with the answer. And and finally, yes, if there's an error in the call, we again call the same function with the error. So if there's an error, we throw the error back into the generator. If there's no error, we pass the answer to the generator, and we get the next value out of the generator. So that's all this does. It's just a loop over the generator. So now that we have this function, here's the same code to read two files done using a generator. So again, we have a read file function that returns a promise. And we have our main function, which is a generator. And now it's really simple. We basically yield two calls to this. We output it. And if there's an error, we catch the error here. And then at the very beginning, we call run generator main. So one nice thing to note here is, apart from the fact that it's much easier to read and understand, is you can actually catch the error using the normal try-catch mechanism you use for synchronous code. So this reads like it's happening synchronously, even though it's actually happening asynchronously. And that's really the nice thing about it. Yeah. Did everybody get that?
Can you go back to previous page
The
again?
big function?
Yeah.
This one?
Yeah. So can we go over these things again?
Sure, yeah. Okay, I'll go just bit by bit. So the generator function, the first parameter we pass here, that's basically, that's like passing the main function here. So we haven't called the generator function yet. So inside here, we then call it here. So we get the generator. So then we declare this is like an inner loop, there's gNext function, right? So we call the gNext down here with nothing to just kind of kickstart the generator. So just don't worry about this parameter just now. The first time we call it, it comes here, so it calls next from the generator. So get me the next value from the generator, and as you do that, pass in here's the answer from the previous call. That's it. Okay. And then we then check if we're done yielding values from the generator, there's nothing to do. If not, then assume that this value the generator has given us is a promise. So what that means is the read file function that we have. So when we're actually yielding a promise, which is a call to this function to read the file. That's basically it. So we wait for that promise to resolve, and after it's done, we get the answer, which in our example code is the contents of the file, and we then pass that answer back into the same function up here. If it failed and there was an error, then this will catch the error and it will pass the error back into here. So then in here we check if there was an error, throw the error into the generator. If there's no error, then pass the answer into the generator and get me the next value. And it just keeps doing that over and over and over again until the generator is completely done. Did everyone get that?
Well, can I have one question?
Oh yes.
Why do you use a promise here where you could use another generator?
When I could use what?
Another generator.
We could use another generator.
Yeah.
I'll come to that.
Okay.
I'll come to that.
Yeah.
Yeah. So so that's how it looks with generators. As I said, it's really nice. You don't need to write run generator yourself. So if you use Node.js, the Express, which is a well-known Node.js framework, the guys who write that, well, the guy who wrote that, he wrote this code, which basically is this function, but it's much more comprehensive. It does a lot more work for you. So in that one, you don't need to return a promise. You can return lots of different kinds of things. It will just take care of it for you. Yeah. Bluebird is, this came out in September. This is the fastest promise library right now. It's really amazing. And I mean, if you've held off on using promises because you think the performance is bad, definitely use this because it's really good. There's a performance comparison on the web between this and other libraries, and this beats all of them easily. Okay. Oh yeah. So these 2 bits of code do exactly the same thing. And this is just part of the spec, like a convenience called generator delegation. So you have a generator and you want to yield a call to another generator. Maybe you want to chain generator calls like that. The key thing to see here is the yield has a star after it. So when the JavaScript virtual machine sees that, it knows that, oh, I'm getting another generator here. So it basically does what you see here. So they do exactly the same thing.
What happens if you don't put the star?
Then it doesn't know that, it doesn't think it's a generator, at which point you'll have an error, basically. So this is from the spec. I don't really use this myself, but you can write this as well. So you have 2 loops over 2 different, basically arrays, I guess. And if you write that, this is what it actually internally generates. It generates a generator. A bit strange, but I had to include it because it's apparently it's quite an important part of the spec. So, but don't worry too much about that. Yeah, so in my opinion, generators I hope from what I've shown you, the difference in code between generators, using promises, and using callbacks, which is why that they're probably how we're going to do asynchronous programming in JavaScript in the future. And ES6 also has promises. So I was using a promise library for the examples, but pretty soon, by the end of the year, I think ES6 is supposed to land, right? I think so anyway. So we won't need to use any of the libraries that will be native. This link is really good if you want to see the actual performance, like the speed and memory usage of using generators versus all the other ways you can do asynchronous programming. He's done some good work there. Next up, collections. This, yeah, surprisingly in every browser. It's pretty easy to implement, I guess. Okay. So if you've done computer science at college, then you'll know what all these, well, you should know what all these mean. Set is basically a collection of items where you can't have any duplicates. So it will make sure that there are no duplicate items in the set. So you can see that I add 5, then I add the number 5 again, and it still only counts 2 items. So it also shows that number 5 is different to the string 5. So it goes by time. And yeah, again, same thing down here. So I add 5 3 times, but it still only counts 5 items.
Can I add it, an object?
Sorry?
Can I add the object into the set? Does it compare the 2 objects which with the same?
Yeah, basically. It does the comparison for you.
By value or by reference?
Yeah.
Sorry?
If I have 2 identical objects but with different references, it will be considered 2 objects or only 1 object? Do you know what I mean?
It goes by reference.
Okay.
What happens if you put a mutable object inside the set, then you mutate it, and then you add a copy of it? So they are not
No, it's still reference.
right.
If you mute, if you put an array into the set and push an item on the array, it's still the same array.
Okay, right.
So,
So the
if you shift, if you unshift the it's the same.
So wait, so the comparison is made by reference, not by hashing or whatever.
Yeah.
Okay.
These are just functions for modifying a set. So do I have this item in my set? And size, delete is deleting an item, and clear is take everything out of the set, empty it out. So the key thing to note is you can't access the items in the set using, like, it's the same you do for an array. You can't say, get me the first item, get me the second. You can't do that. You have to use these methods and an iterator. You have to use an iterator to get stuff out of the set. So it's kind of like a black box, more of a black box than an array is, really.
Does it keep the order?
No. Well, there's no guarantee of order. Yeah, there's no guarantee. Map. Map is basically like the normal JavaScript object. There's not much difference from it. You can set keys to values. It's got similar methods to sets, as you can see. The difference between a map and an object, I have it here. Yeah, maps can have non-string keys, so I can actually do set null to hold the value that is, or set, undefined, I guess, to hold the value of this. And also, so if you iterate through an object in JavaScript, usually, you have to use this function hasOnProperty to see, is this property that I'm looking at part of this object, or is it part of its parent object? So if you use a map, you don't have to do that. I don't know what the but's for. That's an important point I was going to say. Modifying a map. Same kind of methods as you have for a set. So again, you can't actually say, give me the first item, give me this. It doesn't make sense. And iterating over a map. I've just taken this from the step. These are all the ways you can look at the contents of a map. So you've got your normal way up here, map.values. Oh, sorry. The normal way is the iterator, which is the same as map.items, where you actually get the values, an array back for each item. The first item is the key, second is the value, or you can go just the values or just the keys, or you can do map.for each. So many different ways you can do this. which also makes it slightly easier to iterate than a normal JavaScript object. So it's another good reason to use a map, actually. Okay. So the final collection I want to show you is a weak map. So it's same as a map. You cannot get the size of a weak map. And that's because it only holds a reference to the object uses key. Okay, so so let's say you have an object and you put the object into a map. Let's say so you have one reference to the object here, and the map holds a reference here. Now you delete this reference, the object will still be in memory because the map is also pointed to it. But if you put the object into a weak map and you delete it from here, then it will also be deleted from the weak map. That is basically the difference between a map and a weak map. The weak map is kind of like it points to objects, but it doesn't actually hold them in any way. Yeah, you look confused. Yeah, I know.
So I just don't know how is it useful, where you can use that.
Okay, so let's say you're looking at your web page, and let's say, okay, give me all the list items on the web page. For each list item, I'm going to create a tag, and I'm going to store all these tags inside this big weak map, right? Now let's say, you can see here, and let's say I remove a list item from the page. I want that map to be automatically updated, and that's basically what it's for. To be honest, I can't think of any of the uses, but still.
I think for caching objects it could be useful. For caching objects.
Caching, yeah, exactly, caching.
Like a big object like images or stuff like that.
Yeah. Here's a code example. I couldn't get this example to work in Firefox. And the reason is, it's impossible to test it. Because, so what happens is, I'll tell you why it doesn't work. So I get the weak map, I set the key and the value, right? I delete the key, but because the problem here is the actual value that the key pointed to, it's still there inside the map. So it's, yeah, there's actually no way of doing this. So I'd have to interact with the DOM, the web page in some way to really test this. But you can look at this code and you kind of get, this is what's supposed to be. You know, if you really remove the key from your program completely, the map should be empty. Yeah. So.
Can't you get like the number of keys from the weak map? Something like
No,
that?
you can't. It doesn't allow you.
Oh, pardon?
It doesn't. You can't get the size. I checked.
There's no API for that.
No.
Oh, okay.
Yeah. Otherwise, yeah, exactly. Yeah. Typed objects. So I'm a bit nervous because Firefox maybe has it now. I don't know. I checked with code examples, so.
That's
Okay.
contribution.
Yeah.
Yeah, it's open source, so.
Oh, okay.
Yeah.
Alright. This is really nice actually, typed objects. If you programmed in C before, it's basically a struct. That's from the spec. I'll try and explain what that means. So you have, let's say you have a chunk of memory, like a big block of memory, and normally you look at that as just one big list. So it's just 10 items in this list. But what if you want to pretend that it has some kind of structure? So you want to say, oh, I'm going to call the first item X, and it takes up 4 spaces. The second item Y takes up another 6 spaces. And I'll just keep talking about this list as X and Y. But underneath, it's actually just one big list. So that's essentially what it's doing. Essentially what's doing. I'll show you the code. It's easy. So this is how you create a typed object. It's called struct type. So they've even borrowed the same word from C. In C, you have structs and unions, and you see programs will not. Oh yeah, UN32. This basically means a 32-bit integer, a 32-bit unsigned integer. So it takes up 4 bytes in memory. So that means the total size of one of these objects is 8 bytes in memory. So I create a new instance of my point 2D. Point is a point on the screen, X and Y. And I can set X to 5, as you can see. And this is what I was talking about. I can then say, get me the underlying storage for this point. Sorry, that should say point 2D, that's my mistake. Get me the underlying storage for the point, get me the buffer, that's an array buffer. how many bytes do I have? 8 bytes. So you can see how it's different to a normal JavaScript object. So normal JavaScript object, you can't do this. You can't get the underlying storage. You can't access the data as just as raw bytes. So that's what makes this really powerful. And then I can use my new type and build other types using this type. So I want to make a triangle. So I have point. So a triangle has 3 corners. So each corner represented by a point. And then I can just construct a triangle just like this. Really easy. And I can reference individual point coordinates like that and set them. And I take my triangle, and I can get the underlying storage of that triangle, and it comes to 24, which is 4 multiplied by 6, because I have 6 values stored. So I hope you can see how this is quite powerful. You can build up a sort of a hierarchy of types, and they all, and at the back end, it's all just one big list of numbers. But you don't have to see that. You can treat them in the structure that you want. So one thing about typed objects is actually let the code speak for itself. So the point here is that when I assign p to c.point, it gets copied. If you think about it, the type is backed by one list of numbers. So if I assign an item into this structure, it cannot reference anything else. It has to copy it into its memory. So that's why when I change this to 5, p to x is still 1, the original number that it was. But this one here will now be 5 after this put x. So that's a little different to how you normally use objects. Because if you're assigning objects, they just get copied by reference. So that's important to keep that in mind. And the UN32 I mentioned, so these are all the possible base, the built-in value types that you can get. And they're fairly self-explanatory. You can, if you're not sure, look into just Google it. A lot of languages have these types. Direct proxies, okay. This is in Firefox. Direct proxies, this is pretty simple. So you have an object, and you want to wrap this object in a way with another object, and then give your client this object, but they have no idea that they're talking to this wrapper. They think they're talking to the original object. That's basically what it is. So that's how it is. So I'll go through this code. So so you have your target, so this is the original object, which is just an empty array. That's what we have. And so what we do, we have a handler. So this handler is what we're going to wrap it with. And the handler is going to intercept a particular call. So this is how we create the wrapper. We use the proxy constructor. So what we're basically saying is, wrap this target with our handler. And then down here, what I've got is a number of calls to show you how this behaves once you have this wrapped proxy. So when I ask JavaScript to tell me, do the toString call on the proxy, it gets the array's toString call. So even though p, as you can see, is not an array, when I do toString on p, it gives me array. When I tell you what is a prototype of p, it says it's an array. What is a type of p? It's an object. Is p an array? True, even though p is a proxy of it. So hope you can see the point of the proxy is to allow you to modify calls made to your original object, but to everybody else, it looks like it's still the original object. That's basically it. And this bit here, p